Hello and welcome to the latest video in a series by EngineSoft UK, exploring the principles behind dimensional management and tolerance analysis. Today we're focusing on mechanical variation, what it is, where it comes from, why it matters to your product development, and how you can keep it under control. Have you or your team ever designed or assembled a product that just didn't work, even after inspection, realignment, or retooling? You checked the drawings, the inspection reports, the CAD model, but that persistent problem just didn't budge? Mechanical variation describes the subtle differences that occur between how a part is designed and how it's actually produced. Every engineer understands that variation exists, but its true impact can be overlooked until it's too late. Every part that's manufactured comes out slightly differently. Features like holes can be offset from their proper position. Angles between features can deviate from their design. Surfaces aren't perfectly smooth. Environmental factors like heat or humidity can warp or expand materials. Every aspect of a part in an assembly can deviate from its intended shape and size in many different ways. Each deviation on its own might seem insignificant, a fraction of a millimeter here, a slight angular deviation there, but across a full assembly they interact in ways that are difficult to predict and even harder to trace. What looks fine in isolation can become a critical fault when everything comes together, and by then you're deep into costly work or redesign. These issues don't just affect product performance and reliability, they affect your bottom line. Uncontrolled variation and unforeseen assembly issues lead to rework, missed deadlines, delayed releases, rising costs, and ultimately, unhappy customers. Engineers and manufacturers have known about these problems for a long time. How can they prevent them? Tolerance analysis provides us with the tools to clamp down on the allowed mechanical variation within our assemblies. Traditionally, tools for tolerance analysis mostly rely on manually constructed spreadsheets and outdated linear dimensioning methods. The challenge is that these tools are too crude to give the full picture of contributors to variation. Worse, they introduce uncertainties at the inspection and quality control stage, leading to inconsistently applied requirements. Enhancing your dimensioning and tolerancing practices from simple linear to a fully geometric specification can make a huge difference in managing mechanical variation within your assembly. ISO GPS standards provide a complete, adaptable language for describing design intent, specifying tolerances, and inspecting your parts. Stay tuned for more videos in our Tolerancing Tooltips series, or check out the Variation Visualize series to learn how to apply this using our 3D tolerance solution CTOL 6 Sigma.